Alright, so we've been talking about buffers, and I know I give you a take-home problem, but I want to talk about one more thing to finish the buffer before I do the take-home problem. So, you know what buffer is. Now, what we're going to talk about is how to make a buffer. How would you make him in lab? And this is one of the useful things that if you go for a job interview, this is one of the questions they ask all the time. How would you make a buffer? Now, there's 3 ways to make a buffer. The first way to make a buffer is the easiest way. You would mix weak acid and its conjugate base. Or you would mix weak base and its conjugate acid. So weak acid and its conjugate, or weak base and its conjugate. That's the easiest way to make it, right? For example, if I have acetic acid and I get some sodium acetate, right? I have a weak acid, I have this conjugate, I buy it, I mix it together. That's the best buffer to make. And to make a best buffer, what you need a 1-to-1 ratio. You have a 1-to-1 ratio that ends up being the best buffer that's good to go. That's the easiest way. So you buy the weak acid, you buy the conjugate, and 1-to-1 ratio, mix it. But what if I don't have everything available to me? There's other ways to make this. Let's say we have the weak acid in lab, but we don't have the conjugate. So here's another way to do it. What you could do, you could mix the weak acid and add strong base to it. So have the weak acid, add a strong base to it. But the strong base has to be limiting reagent. That's really key. Or you can take a weak base, and what you add to it, you add a strong acid to it. Again, the same thing as before. The strong acid has to be a limiting reagent. So how does that work? So again, we have the weak acid or base, but we don't have the conjugate in the lab. But we can somehow make it. So let's go through this. Let's say, for example, I have acetic acid. I have the weak acid. Now, I'm going to add strong base. For example, NaOH. That's a strong base, right? So here, I have the weak acid. I added the strong base to it. Now, what type of problem do I have here? Acetic acid and NaOH. Now, what I have here, I have an acid-base reaction. Don't forget that. I have an acid-base reaction. Every time you have an acid-base reaction is one arrow, is a single arrow. The acid is going to lose the hydrogen. The base is going to get the hydrogen, right? So the acid is going to lose the hydrogen. It's going to become acetate, and the sodium will counterbalance it. And OH is going to get a hydrogen. It becomes water. Now remember, I said the strong base has to be the limiting reagent. So if the strong base is the limiting reagent, that means all of this is going to be used up and you are going to end up with nothing at the end. You following me so far? So what is my final solution? My final solution is going to have some acetic acid and some sodium acetate. So my final solution is going to be a buffer solution. Because this one is all gone, but this is because this is limiting reagent. So I'm going to have some of this and I'm going to have some of this, because some of this will form to this. So I have some of this left, some of that left. This is all limiting reagent, goes away. So I have a buffer solution. So what we did in reality is we made some of the conjugate by having the NaOH, and I end up having a buffer solution. Okay, now the last way. The last way is, what if we have the conjugate, but we don't have the weak acid or base? So again, this was a two-part. Let's look at the last part. The last part, here's what you would do. You would mix strong acid, and again, like before, the strong acid has to be the limiting reagent, and you would add it to the conjugate base of weak acid. Or what you could do, you could add a strong base. You could add a strong base, and the strong base could be the limiting reagent, and you would add it to the conjugate acid of weak base. Okay? So in terms, this is like the opposite of one. You have the conjugate, but you don't have the weak acid or weak base. Okay, so now we couldn't buy the weak acid or base, but what we have in lab, we have the conjugate. So let's do an example, just like the one we did. So let's say we have the conjugate, and the conjugate is sodium acetate. And now what we're going to do, we're going to add a strong acid to it. HCl is the easiest strong acid I can think of. Okay? Now think about this. What type of problem do I have right now? I have a conjugate base and a strong acid. Now I have an acid-base reaction. So what I have here, I have an acid-base reaction. I have an acid-base reaction. And remember, this one is my limiting reagent, right? Is my limiting reagent. So acid-base reaction, which means the acid is going to lose a hydrogen, the base is going to get a hydrogen, so this becomes CH3COOH, right? And then NaCl. So this is a limiting reagent. This is all going to be used up. If this is all used up, at the end, what am I going to end up with? I'm going to have some of the conjugate base left and some of the conjugate acid left. So at the end, I end up with a buffer problem. Again, it's just because I did not have the acetic acid in lab, but I have the conjugate base. That's okay. Conjugate base plus strong acid limiting reagent. Some of this is going to turn into this. This is all going to be gone. At the end, I'm going to end up some of both of them left. So I'm going to have a buffer solution. So these are the different ways of making buffer solution. The easiest way is the first one, but there are other ways to do that. Now let's go back to our take-home problem. Okay, so this was a take-home problem, and what you have in this take-home problem, let's look at how you would read this. You are mixing acetic acid with sodium hydroxide. Okay, so I'm mixing an acid with a base. What type of reaction do I have? I have an acid-base reaction. Okay, let me write this down. So what I have here, I have an acid-base reaction because I'm adding an acid to a base. I have an acid-base reaction. What have we talked about? Every time you have an acid-base reaction, is not equilibrium, right? Is not an equilibrium anymore. What that means is you have a single arrow. And we always need moles or millimoles, okay? We always need moles or millimoles when we have an acid-base reaction. And you also have to think about limiting reagent. So, does it make sense why we have an acid-base reaction? We have an acid-base reaction because what I have acetic acid, I added to sodium hydroxide. I have an acid-base reaction. Now, before I set it up, I said we need moles or millimoles. So let's figure out moles and millimoles before we do this problem. So the acetic acid, I have the volume and I have the molarity. You know, molarity is moles over liter. But there's another way to kind of think about molarities. Moles per liter, or the other way you can do that molarity, it could be millimoles per milliliters. That's another way to kind of look at it that way. Okay, so millimoles per ml, moles per liter is the same thing. It's a little bit, gives me a little bit nicer number. It's easy to do. So for acetic acid, what do I have? For acetic acid is 0.150 molars. Okay, I don't know the millimoles, but the volume is what? Is 100 ml. So what I get for X, I get 10 millimoles. Again, millimoles, the same as moles. I like it because it's like a nicer number. It's a bigger number. Now, what am I do for NaOH? For NaOH, I'm going to do the same thing. What is the concentration of NaOH? It is 0.10 molar. I don't know the moles. How much of the NaOH do I have? I have, oh, that was 200, wasn't it? Okay, I have 100 ml of NaOH. So what I end up for NaOH, I end up with 10 millimoles. I did not do this right I was just trying to test you guys out. So for acetic acid, you had 200 ml. Sorry for that, but I was just trying to make sure you guys know what I'm doing. You're saying awake. So what I have is 30 millimoles. Okay, beside that, did you guys follow me? All I did, I have the molarity, I have the volume, I can figure out the moles. I have the molarity, I have the volume, I can figure out the moles. And what did I figure out moles or millimoles? Because again, acid-base is not equilibrium and you need moles to do limiting reagent. Okay, so now let's do this problem. What we have the acetic acid in this problem. I'll write it down. Plus, my base is NaOH. I'm going to do an acid-base reaction. Acetic acid is going to lose that hydrogen. The Na is going to counterbalance it. And the OH is going to get the hydrogen because it's going to act like my base. Okay, so far so good. My acid-base reaction. Now, when you have acid-base reaction, you have ICF, right? At the beginning, I have 30 millimoles of acetic acid. I have 10 millimoles of NaOH. None of this at the beginning. Minus X and X. What is my limiting reagent? Which one is the limiting reagent? Hopefully you're yelling at me. That limiting reagent is sodium hydroxide. If that's my limiting reagent, then my X is what? Then my X is 10. So minus 10, and plus 10. Because my limiting reagent is sodium hydroxide. I'm going to have none of the sodium hydroxide left. Okay, I had 30 millimoles, and now I'm going to have 20 millimoles of acetic acid left. And here, I'm going to form 10 millimoles of acetate. Now, check this out. This is really, really cool. So I did an acid-base reaction. Sodium hydroxide was my limiting reagent. And I did this ICF table. What did I end up with? I ended up with acetic acid and sodium acetate. What kind of problem is this? This is a buffer problem. I ended up with a buffer problem, didn't I? I started with an acid-base reaction, and NaOH was a limiting reagent, so it went away. I ended up with a buffer problem. And we talked about the ways to make a buffer. That was one of the ways to make a buffer. Okay, so I end up with buffer problem. Now remember, every time you have a buffer problem, you can do the HH equation. That's really, really easy, right? You can do an HH equation. So that means pH is, and I have an acid, is going to be pKa plus log my acid here, which is HAC. The conjugate is AC minus. Okay. Now I don't have the pKa, but I give you the Ka minus log of Ka gives me pKa. Don't forget that. So minus log of 1.8 times 10 to the minus 5. I get 4.74. So here I have 4.74 plus log. Okay, now we're going to come over here. Now remember, this, to be really correct, it has to be molarity of these things to plug it in. It's okay if it's not molarity because the volume ends up canceling out. But if you want to be really, really correct, you would want it to be molarity. But it's okay if it's not, because the volume is the same, because it's the same solution. So the volume would end up canceling out. But I want to do this the right way. So this is molarity. For acetic acid, I have 20 millimoles. Now, after you add everything together, your final volume is 300 ml. So what I end up getting is 0.0667 molar for acetic acid. And I ended up having 10 millimole of acetate. And again, the final volume is 300 ml. That's the final volume. So I have 0.033 molar. Again, it would work out if you just plug in moles instead of molarity, but I want to do it right because the equation should be molarity. And it works out because the final volume is the same, it ends up canceling out. So if I plug it in, what I end up for the pH, I get 4.44 is the pH. This is the pH of our solution. Now the last problem, the last thing it asks you for, does it ask you for that? Yeah, for H plus concentration. How would you do H plus concentration? Okay. Remember, you have the pH. pH is minus log of H plus concentration. You have the pH. You can figure out the H plus concentration. So this is 4.44 minus log of my X. You have to take the anti-log of it. How would you do that? Make sure you get the math right. So that would be 10 to the minus 4.44 to take the anti-log of it. Now if I do that, what I end up getting for the answer, I get 3.6 times 10 to the minus 6 molar. This was a big problem. Remember, we started with acid-base problem. Acid-base, you have to do millimoles, you have to do limiting reagent, but we ended up with a buffer. You have a buffer, you do the HH equation. Okay, next time I'm going to do more problems like this. But hopefully you guys are getting this down. Good job.